Welcome to the channel RAK Learner for JEE Mains and Advanced. A cubical block is floating in a liquid with one-third of its volume immersed in the liquid. When the whole system accelerates upwards with acceleration of g by 2, we have four options. The fraction of volume immersed in the liquid will change. This is option A. The buoyancy force on the block will change. Option C, the buoyancy force will increase by 50%. D, pressure in the liquid will increase. Okay, let us check one by one. See what happens when a certain body immersed inside a liquid. So this is the liquid what we are having here. Okay, so this is the liquid. The liquid is having a density sigma. Right. So now an object, what they are saying in this question, is immersed like this. A little portion of the body is submerged. How much? It is said one-third of its volume. Right. So V in, that is here. Right. V in. So how much is V in? V in is V divided by 3. What actually V is? V is the complete volume of the body. Volume of the body. Right. So now you must know one more thing. The density of the body is rho. Okay. So sigma is density of the liquid and rho is density of the body. Now what they are saying, the fraction of the volume immersed in the liquid will change when the whole system gets acceleration upwards. See for that what I suggest here, we can simply assume two situations. One is before acceleration. Okay, so before acceleration. So let us think that before acceleration, what happens? Okay, so before acceleration, here, what we can think on the body, that if this is the body and a little portion of this is submerged, the highlighted portion is submerged. I call the submerged volume as V in. The complete volume of the body is V, complete volume, right? So in this situation, the buoyant force on the body is equal to what I can write. It is density of the liquid, volume of the submerged portion of the body into acceleration due to gravity. Meantime, you can observe the weight of this complete body. So W is equal to, it is whole mass of the body can be expressed like density of the body and it is multiplied by volume. It is again multiplied by G. Right. So this is what I can write. So at equilibrium position, at equilibrium, I can simply write this FB is equal to W. That means sigma V in into G is equals rho V into G, and as the G term get cancelled, what I can write, it is rho V in is equals rho, sigma V in is equals rho into V. Else I can write V in is equal to rho divided by sigma into V. So this will be the portion, that is a volume of the body submerged when the whole system is in rest. Okay, so that is what I am calling before acceleration. Now we have to think about such a situation when the body gets a complete acceleration upwards. and the upward acceleration is how much? It is said g by 2, right? So now we have to think in that way. Let us assume it is during acceleration, right? Upward. So here the body is here, right? This is the body under interest. Certainly we doesn't know how much portion has been submerged now, because the complete acceleration upwards is a is equals g divided by 2. This will be the upward acceleration, right? In this situation, we certainly doesn't know how much portion beneath the liquid. Okay, so this is a v in. I call it v in dash now, right? So v in dash is the portion of the body submerged inside liquid during accelerated motion. In this situation, again we can observe something. The net acceleration upward is g divided by 2. In this situation, what it happens, the whole body will feel a kind of a reaction downward, and that reaction will added with the acceleration due to gravity. So net acceleration downward will be now, it is g plus a, otherwise g plus g divided by 2, and it should be multiplied by m. This will be the weight of the body. Okay, so this will be the weight of the body, the which is acting downward. Meantime, there will be Fb dash, the buoyant force. So how much it should be? It should be equal to, so as we written earlier, it is the density of the liquid. It doesn't change with any kind of different motions, accelerated, uniform, nothing, right? So sigma remains as it is, and what we have to write? We have to write v in dash, and here the total acceleration downward, that will be g plus g by 2, right? This is what we are observing. And again, what I can rewrite here is this m can be written as, it is rho v, right? And it is then multiplied by g plus g by 2. So in the situation, if we assume the after getting acceleration, so there comes a situation that the body will be in equilibrium. Okay, so again at equilibrium, what I can write, it is Fb dash is equals this weight, which is say W dash weight. So here what happens, it is sigma V in dash into G plus G divided by 2, which is equals rho into V, which is again multiplied by this thing. So the bracket term get cancelled. What I can write, V in dash is equal to, it is rho divided by sigma into V. So this will be the volume of the body submerged. So just observe the two results, right? So these two results are same. That means uh, what they said in option A, the fraction of the volume immersed in the liquid will change after getting acceleration. So this is wrong, right? So option A found wrong. What about B? The buoyancy force on the block will change. See, before acceleration, how much will be the buoyant force? This much will be the buoyant force. And now the buoyant force will be this much. Just observe these two, right? This is more and this is less, right? So what I can write? I can simply write F B dash is more than FB. This is one of the conclusion. So definitely buoyant force changed, as well as it is increased, right? So now I can simply choose option B as right. the buoyancy force on the block will change. Yeah, definitely. The buoyancy force will increase by 50%. How it is possible? So just we have to observe these two relations. Right. Here is G and here is G by 2. So G by 2 is nothing but the addition of the gravitation acceleration by 50%. Right. So a 50% addition that happened here. So definitely buoyant force also increased by 50%. So this is also correct. The pressure in the liquid will increase. See, it is a different situation that you can observe. Say this is the liquid what we are having. Okay. So during the state of rest, okay, so we just observe a little portion like this, only this much portion. So this is a portion of a liquid, portion of liquid of certain height. Okay, say some height h. So now, what is the pressure at any point at this one? See here, the pressure at this point. Okay, so pressure at this point is, okay, so how much it is rho. I should not use rho here, it is a sigma G into h. Okay, so this much will be the pressure when the body is in, I mean whole liquid is in rest. But now when the body gets accelerated, okay, so when the body is that means the whole liquid is get accelerated upward, everything whatever we are observing, whole thing is now accelerated. Okay, so we simply assume the same portion one more time, this much. So again I am assuming the same height h. Okay, the same procedure, and we are again thinking the motion is accelerated. Here it was rest, now it is accelerated. So the net downward acceleration will be how much? It is g plus g by 2. A is equals g by 2. So therefore an additional value will be added. So now what you have to observe is the pressure at any point here. Okay, so pressure at any point, this one, right? So pressure at this point is rho, I mean sigma, right? So now what I have to write? I have to write it is not simply g, it is g plus g divided by 2. That will be net acceleration due to gravity, and the height h remains as it is. See the two results what we got here and here. So from this conclusion, okay, so from these two conclusions, what we can observe, uh, this pressure say it is P dash and this pressure say it is P. So definitely P dash is greater than P. Okay, so what actually P dash? P dash is the pressure inside the liquid during accelerated motion, and P is the pressure inside the liquid at the same point uh, when the liquid is in rest. So the result is P dash is more than P. So this concludes that the pressure in the liquid will increase. So definitely it is a good option. So options B, C and D are correct.